let's go over to the interview part. And let's start just simply like, what's the C++ standard you're using in the book?
I'm going for C++ 17 or newer. I tested the code with up to C++ 26, what is available right now, C++ Next or whatever it's called in the compiler settings. So anything C++ 17 or newer will work.
Okay. I think there's a bit of biases for game devs, but like, what audience do you have in mind when you write such a book?
The ideal audience is someone who's interested in how it works. Like I'm seeing something on the screen, I see a game. How is it done? How, as I said, how does the character stay on ground? If I have an AI buddy, does he follow me? This is the part where you want to know the possible implementation, how it's done, and especially a playground to continue. In every chapter, at the end, there are a couple of practical sessions with some enhancements where I say, okay, try to implement this and this and that on this basis, that you can really say, okay, I'm trying to read the code, to understand the code, and to extend it. So if you're curious about all the stuff, animations, levels, loading stuff, and even a bit of GPU programming, yes, the book is more probably perfect for you.
All right. So the book actually has a lot of C++ and a lot of visuals, so you kind of know what you're doing, which I like. What did you learn about C++ while writing the code for the book?
I mostly found the stuff I already loved for the STL functions, that I don't have to write code, because code you don't write has no errors. Most probably your errors. And stuff like std find if or std copy or this stuff, where I just say, okay, please use this container and do something. I found better than doing this stuff by hand. I also try to avoid anything which is older standards like defines, macros, and all these kind of stuff. I try to avoid it, so that I really make a clean modern C++ version for the audience, which also, as tested with C++ 20, 23, 26, which is the part which is available, to be longer on the market, instead of next year, oh, it doesn't compile anymore because some feature disappeared. So yeah, it was trying to get a good future-proof book.
Yeah, I think that's a good strategy. Which, while talking about C++ standards, do you follow the C++ standardization?
I try the best I can. I have the documentation somewhere in my browser as bookmark. The official document, I think I will also get the book from, I think Rainer Grimm wrote the book, where he just put the standard stuff into a book. I try to use it because the better you are behind the standard, the more robust is your code, and not other system, other compiler, and everything breaks because you use something special. No, please follow the guidelines.
Mm-hmm. Yeah, it's nice to know. I've actually met Rainer last week during a visit, and so if you read his books, you're probably familiar with Sippy, which he had also an announcement this week about. But let's continue. And what's your background with C++? You mentioned that you wrote the book not during your day job, though. You're not like a book author 100%. So what's your background with C++?
My current daily job is a gameplay programmer with Unreal Engine, so heavily C++ based. The previous job was also C++ gameplay programming and porting, so console porting, which is low-level stuff. But C++ was for many, many years sort of hobby. I can show you funny thing. My first C++ course, floppy disks, from 98 to 99. This is the time where I started with C++ because I wanted to learn it. I was a bit fluent in C, and then some things are a bit heavy in C to write, and started with C++. And yeah, I wouldn't say love of my life, but I never got rid of it. And even with Java and Python and all this stuff, I know, yes, C++ is my tool of choice.
Yeah, I've also got started with C++ in '98 in high school. But that's a different story. So with a book with over 500 pages and a lot of code written, do you have any known errors so far in the book?
I had 2 small corrections with some UI parts where it didn't behave like it should. And I think there is something in the animation blending which is not 100% correct. I have to check. But right now, I'm not aware of any crashes or any misbehaviors or so. Looks like I wrote a good stable code.
Yeah, that might help against undefined behavior and stuff like that. But generally, I have at least, I mean, it's like when a book is newly released, it's often that the errors are found sometimes like 10 years later or something.
Yeah, that's
but it's an interesting topic to chat about.
Yeah.
So if you have any questions in the audience, then please post them. But then generally, I do also have some more questions. So how does this book help you to write better C++ code?
It should work as a good example how newer standard C++ functions are used, like smart pointers. This is something, as I said, I might overuse it a bit, but not sticking with the old style, keeping your knowledge up to date. It's also one thing Rainer mentioned. You need to be up to date with your C++ knowledge to write good code. And I hope it's a small guiding star where you say, okay, how can I do this? And instead of, there's lots of macro fun. No, there are other ways. How do I do this platform independent, Windows, Linux, OpenGL, Vulkan? Are there any ways to write code which handles all of this without having magic in C++ or some workarounds? All the magic I do is in CMake. And that's all I need.
That's true, and I think it's rather nice that there's now 2 books which, you didn't write a second edition, which you don't have to have the first, but basically you can get started with the first book and then continue into the more advanced book, or basically if you're already like an advanced gameplay programmer and you just want to look into how it's done in a more modern style, which might also just be good to generally have that available as a way to argue to improve your own code base in gameplay way. So if you have more questions, I can ask Michael more questions. But Michael also offered to show us a little bit about what basically the code actually looks like live in action. And I thought this would be a really nice way to, add something which we usually don't have in the interview or kind of, so Michael, this is now your code in action, right?
Yeah, this is a level that was loaded. And you have a couple of instances running around. I can check. There are these are the bounding boxes for collision checking.
Okay.
So you can really see how they are acting. They are used in a dynamic form. Just as an example, you can modify the code and say, okay, I just want to have a single static bounding box. It's up to you. I wanted to have this to be more flexible with any model. And you also can go and say, we have some funny bounding boxes around the models, which are adjustable. So you could also make them bigger or smaller. And I can stop this instance. I have a special flag which says stop movement. That we can show this. Yeah, come on. And this is the visual selection where you can just say, okay, I want to have this instance. Now I want to have this instance. This is some part which I love. Rotate it, scale it, and sorry, Control Z, undo. And if I go for collisions and say, okay, please show me only colliding stuff. Come on. Then you see, oh, you have now red boxes around them. Collision was detected. And the reaction currently is just, well, turn around and try to run away. This is the current stuff. And for the level part, I can maybe show the octree. There's also very interesting stuff that you can see how the octree works at all. Like, oh, I just have one iteration. I have a second one. I have a third one. And depending on the number of elements in the octants, you have more or less subdivisions where you have more elements. We can also go for wireframe. There's a wireframe with normals that you really can, work like in a real game editor. Do all this stuff. My personal favorite. I have a mini map.
Okay.
Of the level. This is fun stuff to see. Wireframe. I can go for gravity. I can show the ground collisions that you also. Let's go on for this. You can really see where the collisions are. And also, oh, there's a wall collision. It's in red, and blue is my ground collision. That you really can play around with it. Oops, there she goes. So another model.
Is that a bug or is that intended?
That's intended. I have a gravity applied, and like in a real game, if the gravity applies and you are out of the level, well, that's it. You're just falling away. I have a special check a little bit below all the level data. The instance gets removed, so they don't fall endlessly. But I can happily go and make some clones. Also a button.
Okay. Well, if I see the clones, what about performance? Have you measured the performance of your code? How many models can you have?
I have a configuration with like 500 anything instances, and it makes only problems if I'm running on Vulkan and try to use stuff like inverse kinematics, because it's a ping pong between CPU and GPU. But in a previous example, there's no problem in running hundreds of instances with animations and behavior with 75 FPS. Now I'm falling a bit down to 60. Yeah, so it's quite fast because these models have also inverse kinematics enabled for the feed. There's also a debug for this inverse kinematics, where you can really get one of the models. Come on, go up there. Thanks. And stop the instance. If we are so kind and disable the gravity for a short while, then I could go and say, you are like a duck. Then you really can see how it works. Gravity on again. This is, I'm now at back to 70 anything FPS. And you can see I also made some IMGUI timers for various stuff where you have performance data. So you can really see where's your bottleneck, what takes ages, inverse kinematics. As you can see, sometimes around 10 milliseconds. It's not optimized, it's a ping pong, so it is a bit slow. But this is also nice tooling to have this. And I think if I disable this, I'm a bit faster.
Is this now also the level editor which you wrote in the book?
There is no real level editor. This is just level loading.
Okay.
So I'm loading.
Okay. Yes. Then that's clear.
Yeah, I'm just loading existing levels and place instances in it to show how the game animation works. Because adding a level editor also here requires another book. And
I understand.
And if I would go for one of the comments earlier was, what about implement rigging? No, you don't do this in such kind of book because rigging is a topic for another book. If I even think of the tooling which is required to implement rigging, you have another book. So this is just how to use the stuff.
What's your next book about then?
Yet undecided. The book took roughly a year of my spare time. So I don't know, writing another book. Yeah, there are a couple of ideas which may be nice, maybe a year or two in between, but there may be more books from my side in the future because it's fun. It's a lot of learning from my side. Most of the stuff here was done learning by doing. Instead of just I knew everything, I knew only a little of many topics, and I have had to work my way around to all of this.
Yeah. So I actually have some feedback from the audience, and then comes a question like in the next chat message. So let's start with the feedback to kind of get the context. Nice. The book looks really good. I think as said, import is the right choice. I could imagine using it as a recommended text in my game development students on the undergraduate module.
Yeah,
we would definitely use. So, and Paul here continues to ask, then you include sound, but also physics, ragdoll, falling down the stairs?
No, sadly not. If you know the physics book from Ian Millington, you will know this is also this thick just for physics, and there are a couple of other physics books. You could start here and implement it by yourself, but it's just collision detection and how the model's running around. Ideas were there, but only a limited number of chapters and pages, so I had to cancel several ideas. That's what I said. Maybe we can write another book, mastering the mastering and doing stuff that was missing, like physics engine. This is a great idea to have a real gravity and maybe have better sound and pick up things and throw it around with physically correct effects. It's not in because it's a huge topic to write, and yeah, time is limited, pages are limited, so sadly not.
And there's a follow-up question. Does the book demonstrate how to create a simple animated model, even just a cube using Blender?
No, this is just about using models and not creating models. As I said, using Blender, I just had a book recently about doing a simple model, and I have a book right now to read about rigging and all this stuff. You would end up with another 200 or 300 pages just to make it really work with anyone who has no idea from all this stuff, and yeah, didn't fit really well into the book. It's just you have a model ready, you load it, and now you use it.
Which makes me wonder, like, I know that often some chapters don't make it into the book. Are there any ideas you had which then, just, would have made the book too big, and the pact was like, yeah, we're not doing that chapter?
I had initially, I think, one chapter more planned, but I can't tell you exactly what we removed. But stuff like physics was definitely on my wish list that I said, could we do some more than the simple gravity, but no. And there are a couple of animations which I was told later, which I added to the practical sessions. Like you have this kind of root motion where your character walks alone and you don't have to control it. You have some not this additive animation with the heads, but what I mentioned already in the first book, that you can split the animation of the model in a top and a bottom part. This all had to be left out. I'm already like 50 or 60 pages above the official limit we had planned. So it's much stuff in there, much more than planned, but I could go on for the next 5 or 10 chapters and say, okay, this. Yeah, I would end like Donald Knuth and writing 5 thick books with 4,000 pages just for animations. You have to wait endlessly.
I think it's easy to get lost in just doing something else.
Yeah, that's why I like the idea of having someone to tell you, oh, this is the number of pages and this is the number of chapters you have to write, because everything else is too much for your audience. You won't get a single book of this size where you say, oof. And if you even already see like 500 pages, it's like, whoa.
That is true. I don't have your book yet, but the last interview we did, I have the CMake book, and that is also kind of it's not 500 pages, but it's like 460 something. So that's already big, and CMake is also like very useful for every programmer.
This book is also on my wish list, so I want to have it to get better in CMake. This CMake for this book is more like, oh, what do I find on Google, and try and error to get it running on all platforms, and I want to really understand how it works.
Then that is a good book to have. So generally, that's I think that the book is just just as I already mentioned in the beginning, it's special for just a certain group, and I really kind of like that Pact actually goes to the effort to do such a book, which is rather specialized into game programming and game animations. So do you have anything to add, Michael, or any more questions from the audience?
No, doesn't look as from my side. I can only add, as you said, it's nice to have Pact on this side where they say, okay, you want to create a book, because I approached them with the second book, not the other way around. The first book come from them, but I said, oh, I still have a lot of ideas left. What can we do? And I made a plan, usually with all this and this and this chapters, and I had to move a couple of chapters around because it made more sense while you were writing. When you say, oh, I'm stepping forward with this animation type, oh, it makes more sense to make it earlier or later. So I like the idea of having someone to give you the chance to write a book, instead of just having a couple of people being able to write books. So this is anyone who wants to go for a book, just do it. It's fun. It's a lot of learning. You won't get rich from it, sadly, but you get the chance to this kind of interviews, and my intention was also to help people to understand it, because I didn't understand much of this, and having someone explaining additive animations like the head animations to you helps a lot to understand it, instead of just, oh, I don't know how it works. Please, guy, go. Come on, guys, stop movement. And if you go for this and say, I want to make him smile. Now he's angry because he wants to punch me. This is another part which is in the book. Yeah, the templates. This is the stuff I explain a lot how to do this stuff. This is all the animation which is here to be seen, this behavior with random values, with weights, with instance changes. And I also explain how to do this in a quite simple way that you may use some things like node-based editor in your code, in your engine, whatever you're writing. And well, the head movement here.
Yeah, that node-based editor looked quite impressive. And it looks nice. Did you write that, or some feature with ImGUI?
This is called IM Nodes. This is based on ImGUI, ImGUI, and you only have to create. I created a class for every of these controls, and you can add context menus where you can say, okay, I can delete it. I can add some node. I can just connect it. It's a lot of fun to work with it, and it makes your life easier.
I believe so. Well, that was an interesting excursion into game development with you, and generally to understand the world of game animations a bit better, which is interesting. And so thank you for your time, Michael.
Yeah.
And
you're welcome. Do I have? Yeah, has been added somewhere. I could probably show. There's my path. This is a navigation target. I'm using a simple model as navigation target. So this is also explained in the book because you have to have some destination. And what is better as a movable destination, to have a movable destination as a model? So it's also explained that you can make any of the models destinations, and then you have also a path drawn. I can think.
And then you can make it walk the path to that target. You just sit on the map.
Yeah, I can think.
Oh, that map looks familiar.
Yeah. That's a version I found on the internet, which I find. And these green things are the paths. And for instance, just walk along it to these nice little not heads, waypoint markers. And if I move it, the instance immediately follows it and the path gets recalculated. And that's nice how to understand how all this path generation works and path following. And as you can see, some automatic light changes. So that's a skybox is also explained how to do a skybox. So this is really your own little small game engine starter project or whatever to understand how it works. It's fun.
Interesting. Makes me curious. Right, Michael. Thank you for your time.
Yeah. What I can two things to add.
Okay.
Shortly before the end. Number one, if you're interested in the stuff I showed and you don't want to get the book first, there's a demo version available. So you can get the executable code from the last chapter and just play around with it. So it's just an exe file or Linux executable and say, okay, start it on the packed landing page for the book. And we have some discount codes available for the book.
Yeah, I think they are linked in the description of the event, and I'll probably also post them under the Linux.
So this is the perfect chance to get the book because you have to pay a little bit less, sadly also for me, but it's worth it.
It's kind of sad to know that the 15% also gets, from your salary taken then. But that's actually something you just mentioned, which makes me curious. You said Linux. So I didn't wanted to ask about, multi-platform, etc., because this is game programming and often it's, Windows. But so your code actually runs under Linux.
Yeah, it runs even on a Raspberry Pi. I have the Pi 400 at home, and you can compile and run the code with the Vulkan version of the code on that machine, and it runs okay-ish. So even on this machine, the code runs without any changes, all done by CMake and planning and fixing interesting bugs with the Vulkan implementation. But yeah, it runs out of the box. You can get the code and Visual Studio. You can use MSys2 under Windows. You can use GCC under Linux, Clang under Linux. It's all working. You can compile it with OpenGL, with Vulkan. So even if you have a potato PC, which is 10 years old, which I also own, like a 4 cores and like a GeForce 750 or so, or an old laptop 10 years ago with an integrated graphics, it works. So it's no reason to say I can't run this code. No, it works on really, I would say, potatoes.
And that's actually a really nice ending that, the code is really portable. So if you want to play around with that, I guess you're already playing around with that. And so don't want to stop you from playing around from that right now. So I guess we want to come to the end. Thank you for your time, Michael. Thank you for the questions from the audience, and generally also thank you for Pact for just providing the necessary means for this interview.
Yeah. I can also say thank you very much for inviting me. Thanks for the questions. Thanks for letting me present my book.
Yeah, you're welcome. So yeah, that's